After we learn about the first type of the second order linear equations, namely the homogeneous equations, we also want to learn about the non-homogeneous second order linear equations. And let us check the PDF article at the oxford.edu. As you can see here, this is the standard form of the non-homogeneous second order linear differential equations. We've got the second derivative here, and the constant of this derivative is 1, and we've got here the first derivative of the function, and the constant is just px, and this is the function itself with a constant of qx, and the right hand side is not 0, but the right hand side is gx. For this case, then we can also find many solutions for this. Theoretically, yeah, we can find many solutions for these equations. And if we have the solution for these equations, y1 and y2, then there is a nice relationship between these two equations. Let me give you kind of a bit more actual example of this. Okay, first let me write an equations here, second order equations. And non-homogeneous equation as well. So here just put ln x or something, or maybe we can use this constant coefficients. It is also alright. Yeah, 6, and here we've got maybe 8 maybe equals to, let's say here equals to x squared. Yeah, this is a second order linear differential equation that is non-homogeneous because we've got x squared at the right hand side of the equations. So from this equation, let us just assume that we have two solutions. It is y1 and y2. So one of the interesting or useful fact about this solution is they are, you know, uh, they can be related into something like this. Yeah, yeah. So if we take the difference between y1 and y2 here, yeah, so we will obtain some function here. Yeah, and this function is actually a solution for the, for the corresponding homogeneous equation. So if I have here equals 0, then the solution for this, for this homogeneous equation is actually in here. So y1 minus y2 will be a solution for the, for this corresponding homogeneous equation. Or I can also say that, because this is a solution for the homogeneous equation, I can also write this right hand side into something like this. Okay. So a more complete story about this result can be obtained from this PDF, as you can see here. Uh, yeah, this is the final result, that the difference between the solution of the non-homogeneous equation will give you a solution for the corresponding homogeneous equations. Yeah, and then if we rearrange this result into something like this, yeah, or let assume that we already know one solution from these two. let's say we already know y2 here, the big y2 here. So yeah, we can obtain y1 as using this, using these relations. Okay. So this final formula tells us that the generic solution, this is the generic solution, or general solution for the non-homogeneous. The general solution for the non-homogeneous equation can be stated into this formula. So it comprises two components. The first one is particular solution. It is called the particular solution of the non-homogeneous equation. And we need to know at least one particular solution somehow. And the general solution will consist of this as the first part, and it also has the next part, which is the which is the generic solution for the corresponding homogeneous equation. Corresponding homogeneous equation. Okay, so now our task for this to solve the to solve this non-homogeneous equation uh, will include a number of steps. The first one, we have to find the second part first, I think. So we need to find the general solution for the corresponding homogeneous equation. After this, and the second step, we want to find at least one particular solution for the non-homogeneous equations, and we will be discussing more about this in the next slide.